In this video, I'm going to show you some of the solutions for the additional practice on slopes and lines. I'll be doing problem number 1, problem number 3 through 7, as well as 11, 12, and 16. Okay, in problem number 1, it says a triangle has vertices at A 4, 1, B negative 2, 3, and C 2, negative 3. Find the equation of the altitude through A, which is obviously then perpendicular to BC. So let's do a quick sketch of these points. A is at 4, 1. Let's put that over here. B is at negative 2, 3. Let's put that up here somewhere. And C is at 2, negative 3. Down here somewhere. Okay, again, I want to find the equation of the altitude through A, which then would obviously be perpendicular to BC if it's an altitude. So let's kind of sketch that in. Would look something like that. All right, think about writing the equation of a line. You need two things. You need a point and a slope. Well, if you look at the line you've sketched, I believe you already have a point. This point is on the line. So we're good there. We also, however, need the slope, and the slope formula requires 2 points, which we do not have. We only have point A on the slope. But we can use this idea that it's perpendicular to BC. So if I find the slope of BC, that is y minus y over x minus x, which would be 6 over negative 4, which would be 3 over negative 2. That is the slope of BC. If I am perpendicular to that, right, my slope would be the opposite reciprocal, which would be 2/3. So now that I know a point and I know the slope, I can write the equation of the line, and I can use point-slope form. So my answer would be y minus 1, the y coordinate, equals 2/3 times x minus 4, which is this x coordinate here. So that would be my answer. That's number 1. Below it, let's take a look at number 3. We have a quadrilateral with 4 vertices, and we need to show that it is a rhombus. So if you remember back from our quadrilateral days, to show it's a rhombus, first we need to show it's a parallelogram. And then second, the special property that a rhombus has is that the diagonals are perpendicular. All right, so step 1. I'm going to label these points. Let's call it A, B, C, and D. I'm going to go around. I'm going to find the slope of AB. That is y minus y, so 5 minus 4 over negative 2 minus 5. That's 1 over negative 7. That should probably match then the slope of CD across the rhombus. So if I look at the slope of CD, I do y minus y over x minus x. That's going to be negative 1 over 7. I can see that those two are parallel. Again, I'm working on step 1. I'm showing that I have a parallelogram. I'm showing that opposite sides are parallel. I'm now going to do that for the opposite two sides. So I'm going to look at the slope of AD. The slope of AD, that's using this 5, 4 and the 6, negative 3. So y minus y over x minus x gives me negative 7 over 1. And then the slope of BC, which would be across from it, that would be using these 2 points, would be y minus y over x minus x. That comes out to be negative 7 over 1. Those slopes are the same, so those two sides are parallel. So thus I have a parallelogram. Step 2, I need to show the diagonals are perpendicular. Okay, so the diagonals are going to be AC, all right, because they are not in sequence, so they have to be across from each other. So if I look at that slope, that's y minus y over x minus x, and that simplifies to -6 over -6, which is 1. Now the other diagonal would be b and d, because those are not adjacent points. So if I take the slope of BD, that would be y minus the y coordinate over x minus the x coordinate. That simplifies to -8 over 8, which is -1. I can see those two values are opposite reciprocals, therefore they are perpendicular. And since I have a parallelogram whose diagonals are perpendicular, I would have a rhombus. All right, example number 4. Triangle ABC is isosceles. They give you two of the points, B and C, and they give you one of the coordinates of A, and you're looking for the x coordinate of A. So again, let's start out with a little sketch. I have B as -2, -1. I have C as 1, -4. All right, and then A, all I know about A is that the y coordinate is 1. So it's some x with a y coordinate of 1. Well, all the points that have y coordinate 1 are on this horizontal line. All right, so I'm just going to pick some random point here, and I'm going to label it x1, and that is point A, and I know that makes an isosceles triangle. The base is BC, so in that isosceles triangle, it's side AB that has to be congruent to side AC. All right, now we can use the notion of distance. If these two sides are congruent, I have coordinates, so I can find the distance of AB. That would be the square root of x minus -2 quantity squared plus 1 minus -1 quantity squared. If I simplify that, that's x plus 2 quantity squared plus, this is 2 squared is 4. All right, and then I know that should be the same as the distance of AC. So I'm going to use my distance formula again. That's x minus 1 quantity squared plus 1 minus -4 quantity squared. So that is the square root of x minus 1 quantity squared. 1 minus -4 is 5, squared is 25. Again, if it's isosceles, these two distances have to be equal. So I would set the square root of x plus 2 quantity squared plus 4 equal to the square root of x minus 1 quantity squared plus 25. I can easily square both sides and eliminate those square roots. So I'd have x plus 2 quantity squared plus 4 equals x minus 1 squared plus 25. Now I'm going to multiply out those squares. X plus 2 quantity squared, that is not x squared plus 4. Remember, we need to FOIL, so that is actually x squared plus 4x plus 4. Then I have this additional plus 4. X minus 1 squared, again we FOIL, we'd get x squared minus 2x plus 1, and then plus the 25. You can see your x squareds are going to cancel out. I'm left with 4x plus 8 equals -2x plus 26. I'm going to have to continue on over here. Let me rewrite this. 4x plus 8 equals -2x plus 26. Now if I solve, if I add 2x over to the left, I get 6x. If I subtract 8 over to the other side, I get 18, and if I divide, that leaves me x equal to 3. So the coordinates of point A would be 3, 1. Okay, let's take a look at problem number 5. This is similar to an example we did, but the lines are a little bit harder to work with. So if we do kind of a rough sketch here, find the area of the triangle whose sides have equations y equals 3x plus 2. So let's focus on this first. The y-intercept would be 2. Let's put a little note there. And the slope would be 3, so that would be up 3 over 1. So maybe a line that looks something like this. That's my y equals 3x plus 2. Then I also have the line y equals negative 10. So if you remember Vux Hoy, Hoy has the y, so that's a horizontal line down here at negative 10. That's that line. And then x equals 3, Vux, that's a vertical line. If I put that in here, that would cross the axis at 3. So let's kind of define this region here so we can see it. Hopefully you can see it is not just any old triangle, it is a right triangle. So in order to find its area, we're going to need to know the length of the segment and the length of the segment. Well, this is a horizontal segment, so I should be able to do a right minus a left on coordinates. This is a vertical segment, so I should be able to do a top minus bottom on the y coordinates, but the problem is I don't know what those coordinates are. But I can see right here, right, this point pretty easily because I went 3 to the right to get to this vertical line and I went 10 down to get to this horizontal line. So that one I can do pretty easily. That's positive 3, negative 10. These other points here are going to be a little bit more work. So this point right here is the solution to the system of y equals 3x plus 2. That's this slanted line, as well as the vertical line, which is this x equals 3. So I need to solve that system to find that intersection point, which is actually pretty easy since this is just x equals 3. To do that, I could say, well, y equals 3. I could use substitution and plug the 3 in for x, which gets me y equals 9 plus 2, which means y is 11. So therefore, I know the coordinates of this point are 3 for the x and 11 for the y. Now I also need to come up with the coordinates for this point right here. Similarly, I can see that point is the solution to the system. Well, it still has this diagonal line, so we're still using the y equals 3x plus 2, but it's where that line intersects the horizontal line. The y equals negative 10 was the horizontal line. So if I solve that system, if I put negative 10 in for y, negative 10 equals 3x plus 2. Subtract the 2. That would be negative 12 equals 3x, and I'd get x to equal negative 4. So now I know the coordinates of this point right here are negative 4 on the x, and then the y value, of course, has to be negative 10. All right, now let's go back. Remember, we're calculating area, which is 1/2 base times height. So this right here is the base. All right, to get that base, I'm going to look at, it's a horizontal segment, so I'm going to look at the x coordinates. Well, the x coordinates here for that segment are negative 4 and 3. So if you remember how we get these segments, we do right minus left. 3 minus negative 4 is 7. So that's going to be my base. Similarly, I need the height, right? This segment right here is going to be the height. That's a vertical segment. A vertical segment, we're going to look at the y coordinates. So for that vertical segment, The y coordinate up at this point is 11, and the y coordinate at the bottom of that segment is negative 10. So to get that that vertical segment, remember we do top minus bottom. So I'm going to do 11 minus, and then this coordinate, negative 10, that comes out to be 21. All right, now I need to put the 1/2 in there. Don't forget your formula. And then 1/2 of 7 times 21 just comes out to be 147 halves. Okay, again, the hardest part of that is finding these coordinates first of all, and then realizing on a horizontal segment you look at x coordinates, right minus left. On a vertical segment you look at the y coordinates of the endpoints and you do top minus bottom. All right, last one on this page is number 6. It says, for what value of A are the following points collinear? Collinear means they would make the same line. If they make the same line, it means the slopes would have to be the same. So I'm going to look at the slope, let's say, of PQ between those 2 points, and if they're collinear, that would have to be the same as the slope of QS. Well, the slope of PQ is y minus y over x minus x, and the slope of QS would be a minus 1 over 2,635 minus 7. So if we clean that up, this comes out to be 2 over 4, which reduces to 1/2. And then over here, I have a minus 1, and then 2,635 minus 7 is going to be, what, 2,628? All right, that's a proportion, so to solve it, I can cross multiply. I can get 2a minus 2 equals 2,628. If I add the 2 over, that's 2,630. And if I divide by 2, that's 1,315 for my A value. That's problem number 6. All right, on the next page, we won't look at all of these. Let's look at number 7. Number 7 says, determine the value of K such that the line containing those 2 points is parallel to the line containing 3, 5, and negative 2, 8. So again, we know that parallel implies that the lines have the same slope. So this is going to be similar to the last problem we did. I'm going to take the slope of the first 2 points, these 2 right here. That would be y 5 minus the y. Notice I'm using parentheses to make sure I distribute this minus sign. And then 2k minus the x coordinate. Again, I'm using parentheses, k plus 3. That should have to equal the slope of these 2 points, which would be 8 minus 5 over negative 2 minus 3. So if I simplify, that's 5 minus k plus 3 over 2k minus 3 equals 3 over negative 5. 5 plus 3 is 8, so 8 minus k. 2k minus k is k minus 3 over 3 over negative 5. If I cross multiply, because I have a proportion, I have negative 5 times 8 is negative 40. Negative 5 times negative k is plus 5k. 3 times k is 3k, and 3 times negative 3 is negative 9. If I subtract 3, I get 2k. If I add 40, 40 minus 9 is 31. So k would be 31 halves. There's the answer to number 7. All right, we're going to jump down now and look at 11 and 12 here on the bottom. Parallelogram GHIJ has coordinates 0, 0. We can see that. Let's label H here. This is PQ. I we don't know, and J is R0. So this reminds me of problems we did earlier where I gave you specific values and asked you to find the missing 4th coordinate on a parallelogram. If you remember, we used the idea of slope. We said to get from J to I would be the same as the pattern to get from G to H because the slopes are the same. So whatever I rise and whatever I run should be identical. Well, I'm starting at 0, 0, and I'm ending at PQ. So you should realize that I'm rising this y coordinate, which is Q, and I'm running the x coordinate, which is P. So I'm going up Q and over P. So that means that's exactly what I want to do down here. I want to go up Q and I want to go over P. Now think about where you're starting, right? We're starting at R0. And think about your coordinates. When I'm rising Q, that has to do with the y coordinate. So the y coordinate here was 0. So if I'm at 0 and I go up Q, my final coordinate is going to be Q. I'm running P, but I'm not running from 0. I'm running from the x coordinate here, which is R. So if I'm at R and I move down P, I would be at R plus P. So it's all about knowing where you start and then what values you have to add on. This is the x direction, so I'm adding to x. This is the y direction, so I'm adding that to y. All right, 12 is similar. We have a rhombus though this time, and we know on a rhombus all the sides are congruent, so let's keep that in mind. We're at 0, 0. This point again is at PQ. This time I don't know V or W. So let's start out the same way. I know I'm going to have to go up Q, and I'm going to have to go over P. And that's the pattern I would have to continue. But the problem is I don't know where I'm starting from this time. On the problem before, I knew I was starting at R0. So where exactly is this W? Well, the trick is all these sides are congruent. If you look at the lines I drew in right here, hopefully you see we have a right triangle where this distance is Q and this distance is P. So I could say, using Pythagorean theorem, that Q squared plus P squared has to equal this segment TU squared, which means TU, that distance, would be the square root of Q squared plus P squared. But if that represents this distance, it also represents this TW distance, since in a rhombus they're all congruent. So if this distance is the square root of Q squared plus P squared, point W is square root of Q squared plus P squared, comma, 0. So that's the big difference from problem 11. You have to find this coordinate first, and you can do that because it's a rhombus. Now from that point, I need to go up Q, right? But if I'm going up Q, that's from the y coordinate. So my y coordinate would be 0, and up Q is just going to be Q. And then I need to go over to the right P. That's onto my x coordinate. So if I'm starting at the square root of Q squared plus P squared, and then I'm moving to the right P, my coordinate would be the square root of Q squared plus P squared, and then I'd add on P. That would be the coordinates of point V. This would be the coordinates of W. I think they asked for both. Okay? All right, let's take a look at one more problem. I think we're going to look at number 16. This one is similar. We have a square PQRS. P is at 0, negative A. Q is at 0B, and R and S we don't know. Similar to the last problem, it is a square, so we know all of these sides are congruent, and we're going to use that in the same way. Right? I think we know at R that this point is equally as high as this point. So you should be able to tell immediately that the y coordinate here must match the y coordinate here. Similarly down at S, right, the y value here would be the same as the y value at P. So if P is down at negative A, S would have to be down at negative A. The question is, how far to the right did I go? What is this x value? How far did I go? Well, remember, these distances match these distances. Here I have two sets of coordinates, and this is a vertical segment. So remember, on vertical segments, I would look at the y values, right? And if it's a vertical segment, I would do top minus bottom. That equates to b plus a would represent that distance. But since it's a square, if this distance is b plus a, so are these horizontal distances. So I'd be moving b plus a to the right. That would be my x-coordinate for both of those points because it's the same distance out. So those would be my answers for R and S.